Welcome to the new video of the series, Learning Kubernetes with Nimbella. In this series of videos, our goal is to teach Kubernetes, building a serverless environment. Following us, you are going to understand how it works. This is the second lesson of the course. We already did another video, in where we explained Kubernetes architecture and the advantages adding serverless to it. In this video we start to see something practical. I will show how to create a Docker image with a version on OpenWhisk, and I will show how to build it step by step. We have already seen in the previous lesson what is OpenWhisk, and what is the purpose of serverless. I make now a brief summary. We know that you can create in cloud environments based on Kubernetes. However, they are usually complicated to build. In particular, it is difficult to refactor our code, monolithic, into a microservices architecture. Using an environment such as OpenWhisk, we are able to use a Kubernetes architecture that is ready, which can use simply sending our code to the cloud for immediate execution. Generally speaking, building a complete environment based on OpenWhisk requires the configuration of many components. This is the subject of this course. Luckily, OpenWhisk is very modular and you can build an environment incrementally, adding more components step by step. You can have a complete environment and a single Docker image. You can then add more components afterwards. To understand what it is, let's now see our OpenWhisk running. We will deal later with the complete configuration of the architecture that we have seen in the figure. We can start in a very simple way. OpenWhisk can be run in standalone mode, consisting of a single controller that incorporates all the other features. It is therefore ideal for beginners. In this first video we will see exactly this, the execution of the OpenWhisk in standalone mode. Without any further ado, let's now launch OpenWhisk by running this command line, which is very complex, but we will explain it in detail later. I'm basically starting from the end, because it's easier to understand by looking at the final result. If I run this command, as you can see, I have launched OpenWhisk, that is producing a lot of log output. It is not necessary for now to understand this output in detail. Let's now try to see what happened. As I think you already know, Docker creates containers, starting them from images. A container is similar to single virtual machine, and it is like a standalone server. Technically it's a bit different, but for our programs, a container is like a server dedicated to it. If I run docker ps, I can see the containers running. You can see that we have started our OpenWhisk, but you can notice that, in turn, other additional containers have been created. Those containers correspond to the executors of the function. Let's see now the user interface that is available for OpenWhisk. It is the playground. It is an environment where you can simply play with code, experimenting with writing functions, and testing the immediate execution. Let's pick now one of the examples, and then let's run it. Now, I change one of the strings. Next, I click the button for the execution. You can see how I can change the code, and then get it running immediately. It is also possible to pass parameters to a function and see the results. We have just seen how to create and execute a function, using the playground. The playground itself should be considered an environment of practice and experimentation. It is not the normal development environment. For actual development, you should use the command line tool, starting with a function like the one you see in the figure. Now, let's open a terminal and run the command to create a function. Later, using the same command, you can invoke the function. Let's see this in detail at the terminal. Before all, we notice that the command line tool can connect to different OpenWhisk environments, using different credentials. The required informations are the usual ones: a user, which in our case is an identifier, and a password, which we call a key here. We also need to specify where our OpenWhisk is running. We name this parameter the API host. We now assign some values to environment variables. We use the default values of the local installation. We can change those values if needed. But our serverless environment will only be accessible on our local computer, so the default values are just fine. With the command you can see, I am assigning the parameters for accessing the local OpenWhisk. Note that starting from now, we are going to call actions the functions. OpenWhisk uses the action to mean functions. Now let's try to create an action. We already did it before, in the playground. Let's do it again, but using now the command line. Let's first give a look at the source code we have prepared in a file. There are no surprises, it is the same code. It simply returns a greeting message, possibly specifying a name as a parameter. Now I create the action. Here I have used the command create. First, I give a name to the action. Then I specify the name of the file where the code is stored. Let's now try to invoke the action. We can see the expected result. Now let's try again, using the -p flag, which allows to specify a value for a parameter. As you can see, the answer shows the name. You may have noticed that I also specified the -r flag. This is because I want the result to be returned immediately. Generally speaking, however, invocation of actions is asynchronous. If I invoke an action without using this flag, it only returns an identifier for the request. This identifier is called an activation identifier. I collect the identifier, copying it into a variable. Now I use it to see the value returned from activation. As you can see, it returns the value corresponding to the latest invocation.
Now, let's learn all the steps to build a Docker image. We will build the image compiling from the sources. For this reason, we are going to learn how to compile OpenWhisk. This is an essential preliminary step, in order to create the Docker image. To be able to compile OpenWhisk you require 3 software. First, we need Docker. OpenWhisk generates a Docker containers for each action, so it's an essential component. OpenWhisk itself is written in Scala, which is a Java-based language. For this reason, we need a Java virtual machine for its compilation. We must therefore install the Java Development Kit. Also, some components, such as the playground, are written in JavaScript. For this reason, we need also Node.js. These are components that many developers have already installed. However, finding from the net generally takes just a few minutes. We therefore are not going to show the installation of the required components here. Once we get these components, we simply need to download OpenWhisk source code, then execute a couple of commands. The first command is the command required for the compilation. The second command is the one that starts OpenWhisk locally. Let's see it in practice. First, let's check that we have the required components already installed. Now, install the OpenWhisk command line tool. We can proceed with the actual compilation. We use Git to download the source codes directly from GitHub. You can download and compile one of the released versions. I prefer to build it from the latest sources on GitHub. It is generally containing the latest features and bug fixes. Let's start compilation. And wait, it can take a while. Once compilation finished, we can use this command to locally launch OpenWhisk.
Now you learned the basics about using and compiling OpenWhisk. In the next lesson we are going to learn how to build a Docker image for OpenWhisk.